Hello, I'm Richard, and I'm going to make a machine that can find things. I'm going to make a machine that can find oil and gas reserves underground. It can find hidden tunnels. It could even find landmines that could potentially kill people. How I'm going to do this is I'm going to make an extremely sensitive gravity sensor. It's going to be so sensitive, in fact, that it could measure the gravitational pull of any one of you in this room. And it's also going to fit inside a golf ball. So what is gravity? Gravity, you all know what gravity feels like on Earth. We know that gravity, any object with a mass feels an attraction to anything else in the world with a mass. We call this acceleration that results g, and its magnitude is given by your distance away from something and the size of the object that's attracting you. So we know what it feels like on Earth. On the Moon, it would be smaller because the Moon is smaller, and on Jupiter, it would be bigger because Jupiter is bigger. As we go down to smaller scales, we start to see the influences of smaller and smaller features underground. To eventually, like a cartographer plotting altitude, we'd be able to make a map of the density of the ground underneath us. So how attractive are you? I mean, say from this distance here, you're attracting me at about 2 billion, so 2 with 9 zeros after it, times smaller than the ground is attracting me just now. So this is how attractive you are, and this is how attractive I need to make my sensor in order to make it usable. So, has this been done before? Yes. I mean, in fact, a lot of you have got one in your pocket. iPhones or any smartphone have one of these, and as you tilt your phone to the side and it turns sideways, that's a little accelerometer, which is the same thing, but it's 100,000 times too insensitive for what we need to do. You also get ones that are sensitive enough to measure a human being's attraction, but these are about the size and weight of a sofa. We plan to incorporate the smallness and cheapness of the ones that you get inside a phone with the accuracy of the big sofa-sized ones, and could potentially revolutionize the field of gravity sensing, because these things could be flown in satellites, they could be flown in planes easily, and they could even fit down boreholes. So how do we do this? My sensor consists of two things. Firstly, a mass on a spring. The mass is attracted towards heavy stuff. And then secondly, a sensor which measures by how much it's attracted. So I'll firstly mention the first part. You have a mass on a spring. So imagine a bowling ball. You can all imagine that. Say my head. It's about 5 kilograms, and it's suspended on 7mm thick cantilevers, and it'll bounce up and down like this, and that'll be very, very soft. Scale this right down in this dimension. Scale this right down to about the size of your fingernail, and you have our measurement. We'll also have a sensor which can measure down to an accuracy, an optical sensor down to a few atom widths. We're just starting fabrication now, so if you want to an experimental answer to the question, then give me a call in a couple of years. Thank you.